All right, guys, coming back at you. In the last video, Livy and I introduced the concept of a mole. The Molly mole. And the fact that the mole represents a counting number in chemistry. And that 1 mole is equal to the equivalent of 6.022 times 10 to the 23rd particles. So there are a lot of particles packed into this number. So when we talk about the mole, there's something that we need to address, and that is, even though the number of particles is the same, the mass differs depending on what substance we are measuring. And so when we are doing this, we're going to go ahead and start with a generic example like the warm-up, and then we'll compare actual masses of different substances like sugar and baking soda and salt. So let's go ahead, Livy, and we're going to rank mass of watermelons and mass of elephants. But let's start with this. When I use the word dozen, how many watermelon are in a dozen?
12.
Yep.
And elephants is 12 also.
Okay. So what's the same when we compare elephants to watermelons?
1 dozen.
Mm-hmm. They're 12,
Yeah.
right? Okay, so when we compare 1 mole of watermelon to 1 mole of elephants, based on chemists and our counting number, we now know that 1 mole of watermelon and 1 mole of elephants is equal to 6.022 times 10 to the 23rd particles, which is Avogadro's number. Now, let's think about this. That would be a lot of watermelons, right?
Yeah.
If we were to take 6.022 times 10 to the 23rd watermelons,
That would fill up our living room.
I would say even bigger, probably our neighborhood.
Nah.
You don't think so? That's a lot of watermelons.
But, like, the watermelons are smaller than the elephants, so the watermelons would take up a smaller space, and our living room is pretty big, so.
Okay. All right, so that's a good point, though, that the watermelons are going to take up less area, less room. So if we had a mole of elephants, 6.022 times 10 to the 23rd.
That would fill up the state.
That would fill up probably more than the state, maybe the country.
Maybe, just maybe, every single apartment in the world.
Yeah, maybe, but we're in quarantine now, so the elephants aren't getting out. Okay, the point is that 1 mole of each of these, watermelon or elephants, is equal to the same number of particles. But if we were to compare, and this is a big but, get it? If we were to compare the mass of 1 single watermelon, are you listening?
Yeah.
To the mass of 1 elephant, which one would have more mass?
It's obvious, right? Elephant.
Yeah. So if we were to compare the mass of 6.022 times 10 to the 23rd elephants to 0.022 times 10 to the 23rd watermelon, this would be true, right?
Yeah, that would totally be true. But you know what would be false?
What?
Can I have the marker, please?
What's that?
I have the marker.
Oh, now you're switching it?
That
Yeah, that's not right. What did you say about the alligator earlier?
Oh yeah, the alligator goes for the bigger number. Wants to eat the bigger number. He doesn't want to eat the smaller number.
Right.
So when you do these equations like this, you want to put the arrow towards the smaller number and this towards the bigger number. But if you're doing a minus equation, you would want to do that.
You're doing 2nd grade math, which is awesome. Okay, so we're going to go ahead. Obviously, in this unit, we're not comparing watermelons to elephants or watermelons to ants. We're comparing the mass of 1 mole of different substances like copper or aluminum or sugar or salt to other things. So I've already pre-measured, and you guys saw this in the first video. This is 1 mole of water, which is 18.02 grams. And in this 1 mole of water, there are 6.022 times 10 to the 23rd particles. This is 1 mole of salt, NaCl, and we're going to go ahead and actually calculate the mass in 1 mole of salt, which is sodium chloride. And so, Olivia, you can hold that up. In this particle, we've got 1 sodium atom and 1 chlorine atom. And if you use your periodic table, sodium has a mass of 22.99 AMU. And chlorine has a mass of 35.45 AMU. So the combined mass, if you plug it into your calculator, because I did mental math last time and I screwed up in real time, is 58.44 AMU. Now obviously that's the mass of 1 particle of NaCl. If we're talking about 1 mole of NaCl, that's 6.022 times 10 to the 23rd particles. So 1 mole of NaCl is equal to 58.44 grams. Okay? Not to be confused with, so we've done water and salt. We'll go ahead and do sugar. And sugar, which is what I've been consuming a lot of, it's not good, that and coffee. Sugar has a different molar mass because, again, it is a different formula. So sugar, glucose is C6H12O6. So to calculate the molar mass of sugar, we need to add 6 carbon, which have a mass of 12.01, to 12 hydrogen with a mass of 1.01, to 6 oxygen with a mass of 16, and we get a collective mass of about 180 grams. So in 1 mole of sugar, there are 180.18 grams, which is equivalent to 6.022 times 10 to the 23rd particles, which is also equivalent to about the amount of sugar in a unicorn frappuccino at Starbucks. I don't know. I looked it up one year. It was like 2 years ago. It's crazy how much sugar is in one of those things. Not that you can get one now, but anyway. So let's look at some other examples. We've done this for a few compounds that you can find in your home. Let's do it for another thing you can find in your home, which is just aluminum foil. So this is aluminum, and I pre-measured this as well. 1 mole of aluminum, there's that is equal to 27 grams. And 27 grams of aluminum in 1 mole is equal to 6.022 times 10 to the 23rd particles. All right, you guys get the idea. Now I've got a moly mole that I've got to take care of. All right, that's it for today. Signing off. Make sure you do your activity, what is a mole or what's in a mole, for homework, and I'll talk to you soon. Miss you. Bye.